Bright Tuty. Every student matters.
Let's look at some of the examples. We need to prove that root 3 is irrational, right? We will use these contradiction method to prove that root 3 is irrational. While proving root 3 being irrational, we will use a contradiction method. First of all, we will assume that root 3 is rational. Okay, so let's assume root 3 is rational. Okay, so if it is rational, it can be written in p by q form. So root 3 is equal to p by q, where p and q are integers and p and q are co-primes. Okay, first you should write that q cannot be equal to 0, right? Because we are dividing it by q and we cannot divide a number by 0 because it is not defined. So p and q we have assumed as co-primes. What are co-prime numbers? Let us say 4, 5. These two numbers are co-prime because they do not have a common factor, right? These numbers will not have a common factor apart from 1. Okay, so if I take 16 and 17, these are also co-prime to each other. These numbers are not primes, right? But these are co-primes to each other. Okay, so any consecutive two numbers if you write are co-primes to each other. If you write two primes, let us say 17 and 19. Okay, if you write two primes like 17 and 19, these will definitely be co-prime to each other because they will never have a common factor apart from 1, right? So we have assumed here that p and q are co-primes to each other. Secondly, q cannot be equal to 0, right? Now this is what we have assumed because we have assumed root 3 to be rational. Now we will prove by contradiction that it is not. So let's square both sides. If you square both sides, 3 will be equal to p square by q square. So I can write p square equal to 3q square, right? From this expression you can see that 3 is a factor of p square. So I can say 3 divides p square. Okay, from this expression it will imply that 3 divides p square, and from the theorem that we just did we can say hence 3 divides p, right? If 3 divides p square, then 3 divides p also, right? This is what we did in the theorem above. Like we said that if p divides a square, then p divides a. Okay, now so we can write p equal to 3m, okay, where m is an integer. Okay, p is equal to 3m because 3 divides p. Okay, now we will put p equal to 3m in this equation. So 3m whole square is equal to 3q square. See, I can always take p equal to 3m. If some of the students are confused about it, then I have just proved that 3 divides p. Okay, 3 is a factor of p, so I can assume p in the form of 3m, 3n, 3k, right? So where the m, n or k that you assume is integer. So I have put this p equal to 3m in this equation. Okay, so now you see that 9m square is equal to 3q square. Hence I can say q square is equal to 3m square. Okay, and from this equation I can say 3 divides q square, right? Because 3 is a factor of q square. Q square is equal to 3 into something. Okay, making 3 is a factor of q square. So 3 divides q square, hence 3 divides q. okay, using this theorem. Now you see 3 divides P and 3 divides Q. So 3 is a common factor of P and Q, right? Do you see something wrong here? It contradicts our assumption which said that P and Q are co-primes. So they could not have any common factor, but 3 is a common factor of P and Q. Why is it happening? Because our assumption was wrong that root 3 is rational. So this assumption itself was wrong. We started with something wrong, so we arrived at something wrong. Okay, so this contradicts our assumption. Hence, by contradiction, we can say that our assumption is wrong. And what was our assumption? That root 3 is rational. Okay, hence root 3 is irrational. Okay, so this is the algorithm that you will follow if you have to prove root 2 as an irrational number, root 3 as an irrational number, root 5 as an irrational number. If then there is a combination of rational and irrational number, I will tell you the way to prove it irrational. Let us say this is the number 3 root 2 is irrational. Now you know that root 2 is irrational. Root 2 is irrational, right? This is the fact that we already know. Why? Because we can prove it by this similar method. We can assume that root 2 is rational, then you write root 2 equal to P by Q, and you follow all these steps. Okay, then you will arrive at this contradiction, and then you can say that root 2 is irrational, right? Now I have taken this question here that 3 root 2 is irrational. Okay, I need to show this. So I'll start with the assumption that 3 root 2 is rational. So let's assume 3 root 2 is rational. So now if I have assumed it to be rational, it can be written in P by Q form, where Q is not equal to 0 and P and Q are co-primes. This is our assumption. Okay, so if we start with this assumption, then I can say root 2 is equal to P upon 3Q, right? Now I know that P and Q both are integers and Q is not equal to 0. So P by Q is a rational number. Hence I can say P by 3Q is also a rational number. P by 3Q is a rational number. Why? Because it can be written in, it is already written in P by something form, and that something which is 3Q is not equal to 0 because Q is not equal to 0. So I have written it in P by Q form. Okay, so this is rational. This implies that root 2 is also rational, but we know that root 2 is irrational. Hence we can say our assumption is wrong, right? Our assumption is wrong. And 3 root 2 is irrational. Okay, what I mean here is that once you have proved that root 2, root 3, root 5, these are irrational, now it is a fact for you, right? Now you know that these numbers are irrational, and you can use that knowledge while proving other numbers like 3 root 2, and I'll show you another number like this. 5 minus root 3, right? These numbers as irrational, using your previous knowledge that root 2, root 3, root 5 are irrational. Okay. So now let's show that 5 minus root 3 is irrational. The algorithm that you will follow, or the method that you will follow, is the same. Okay. You will start with the assumption that it is rational. You will write it in P by Q form, and then you will manipulate in a way that there will be a contradiction, and that by that contradiction you can say that your assumption itself was wrong. Okay. So let's assume 5 minus root 3 is rational. So I can write 5 minus root 3 in P by Q form, where Q is not equal to 0. P and Q are co-primes, right? So P and Q are such integers that they are co-prime to each other, and Q cannot be equal to 0. So this is our assumption. Now in the next step, this is our assumption. So in the next step, I can say, if I take root 3 on the right hand side, what I can say is 5 minus P by Q is equal to root 3. So further I can say 5Q minus P divided by Q is equal to root 3. Okay. From this equation, you should notice that Q is not equal to 0. So there, and Q and P are integers. Okay. So 5Q minus P will also be an integer. Okay. P and Q are integers. So 5Q minus P will also be an integer. Right. And this integer 5Q minus P is being divided by Q, which is non-zero. Hence I can say this left hand side 5Q minus P by Q is rational. So root 3 is rational, which is the right hand side, but this is wrong. Why? Because we know that root 3 is irrational, right? So there is a contradiction now. Hence, by contradiction, we can say that our assumption is wrong. Hence, 5 minus root 3 is an irrational number. Irrational number, right? Until and unless that irrationality, right? What is the irrationality in this number? Root 3. Root 3 is the irrational portion in this. Until and unless this root 3 can be cancelled somehow, the number will be irrational, right? What I am saying is, let us say there is root 3. You keep adding numbers and subtracting numbers. Let us say 3 root 2 plus 5 minus 3 root 2, right? Until and unless this root 3 gets cancelled somehow, this will be irrational. Why? Because this 3 root 2 is being cancelled. Root 2 also brought irrationality into this number, but this got cancelled by this number, right? But root 3 cannot be cancelled by these rational numbers. So any combination, any such combination like this, 7 minus root 3, let us say 7 plus root 3, these all are irrational. Okay, this is just for your knowledge. So we have proved 5 minus root 3 to be irrational.